integration to example 11. We're moving on to a different method now called integration by parts. I always think this is a little bit similar to the product rule for differentiation, in the sense of we're looking at situations where there are two functions multiplied together, and usually they're different kinds of functions. So in this example we have a polynomial function, 3x, and then we have a trig function, sine 2x. They're different types of functions. This is the formula, it's in the formula book. And what we do is we split the question up into two parts. One of the parts we call u, and in this case I'm going to call 3x u, and I'll talk about why I've chosen it that way around. It's not just because the 3x came first, although it does in this case. And then I'm going to call the second one, which is sine 2x, I'm going to call that dv by dx. So start by writing down which part of the question corresponds to each of the two parts in the formula, and the dx here just means that we're integrating with respect to x. On the right hand side are the things that we need to work out. So we need to know u, which we've already got. We need to know v, which we're going to have to find, v again, and then we need to know du by dx, which we can work out, and again this dx just means that we're integrating with respect to x. So we need u, v, and we need du by dx as well. So let's work them out over here. Now I always set it out in the same way because it makes a little pattern. So underneath the u I differentiate that function, which gives me 3, and underneath dv by dx I integrate it to give me the function v. The integral of sine is minus cos, so in this case it's going to be minus a half cos 2x. Okay. So we now need to work out this integral. So the integral of 3x sine 2x dx is equal to, so we've got u dv by dx with respect to x is equal to uv. So the way I remember it is that we do the sort of leading diagonal, if you like, of this little square. So that's minus 3x over 2 cos 2x, just multiplying those two together, that's u times v, and then we're going to subtract the integral of v multiplied by du by dx. So in other words we now do the bottom two, so it's leading diagonal minus the integral of the bottom two. So it's going to be minus the integral of 3 over 2 cos 2x. We're subtracting it, it's negative, so I'll save time and I'll make that into a plus there. So just pause at this point and check if you understand where each of those bits have come from. We haven't quite finished. So if you're okay with that part, we then need to just do the second integration here. So the first part just stays the same, and then we're going to integrate this. The integral of cos is sine, and we'll have to divide by 2, so it would be 3/4 sine 2x. And because that's our final step, we put a plus c. Now, in terms of why I chose 3x to be u, you'll see that 3x became more simple, it became just 3. And when I integrated sine, it didn't become any more complicated. Cos is no more complicated than sine. So what you're looking for is making one of the terms easier by making it have, say, a smaller power, if it's a polynomial. And on this side, when you're integrating, you want something that isn't going to get any more complicated, if you can. There is one exception to that when we come to integrate log x, and I'll talk about that later on.